Welcome to Module 5, Lesson 4, Dividing Decimals. Today we're going to work with fluently dividing multi-digit decimals. All right, so first we're going to take a look at what it looks like when we divide with decimals. And for this one, I'm going to encourage you to have 3 different colors because of the fact that we are dividing by 3. I am going to use blue and purple and yellow. All right, so what I'm going to do is I'm going to shade in 6 and 39/100ths, and I'm going to separate the model into 3 equal groups. All right, so I'm going to go ahead and shade that in, and I'm just going to shade it in with let's do green. So 6, so that would be this whole thing here. So there's 2, 3, 4, 5, 6, and now I have to shade in 13/100ths. So there's, or I'm sorry, 39/100ths. So there's 10, 20, 30, 39. Now I need to put them into equal groups. So my first group I'm going to circle in purple. So I have 1, 2, 3, 4, 5, 6. So since I have 6, I'm going to go ahead and look and see if I can make even groups with having 2 full in each group. And then let's look at these 39. So if I have these 39 pieces and I divide them into groups or into 3 groups, I get 13. So then here is 10, 13. So let's see if this works then. So now I have a blue group. So 2, and then here's 7, 8, 9, 10, 11, 12, 13. And then last but not least, I have 2. Let's see if this works. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So in each group, I have 2 wholes, and then each of these are 13/100ths. So I know 6 and 39/100ths divided by 3 is 2 and 13/100ths. Okay, well then to double check this, what I can do is I can take 6 and 39/100ths and put it into groups of 2 and 13/100ths. So then I'm going to go ahead and do this way. So I'm going to put it into groups of 2 and 13/100ths. So here's 1, 2, 10, 11, 12, 13. So now I'm going to take my next color and I'm going to do 7, 8, 9, 10, 11, 12, 13. All right, and then I'm actually going to go ahead and say, okay, well, this is going to be a little bit difficult now because I have 4 left over here. So I'm actually going to go ahead and say that, okay, well, here's part of a full group. So to have a full group, I need to have 100. So if this is 13, right now, that means that I have 100 minus 13, which is 87. So then I need 87 plus another 100 is 187. So I need another 13 here. 10, 11, 12, 13. So that's 2 full groups, and now I need 13 more. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Now I'm going to take my yellow. All right, so now here I have 26 colored in, so 100 minus 26. So 100 minus 20 is 80, minus 6 more is 74. So here I have 74 colored in. So now I have 174 colored in. And so I need 26 more, so 10, 20, 1, 2, 3, 4, 5, 6. And then I also need 13 more. 6. So then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so when I did that, I was able to make 3 groups. Okay, so when I did that, I was able to evenly make 3 groups. So 6 and 39/100 divided by 2 and 13/100 is 3. Okay, so let's take a look at what that looks like when we are using long division. Give my board a second to catch up to me here. Okay, so can't see it on the screen, but in your books you can see that we are working on, there we go, multiple representations. So when using models to divide decimals, when might you want to use grids divided into tenths instead of hundredths? So when would you want to use models that were divided into tenths instead of hundredths? Okay, well, let's think about that. We just had a problem where we had numbers that were in the tenths place, in the hundredths place, and it worked out nicely. However, what if we had them where it was only in the tenths place? Okay, so problems that have numbers that are only 1 decimal place long, so to the tenths place, it would be good to use a tens grid instead of hundreds. Okay, so here we go. Let's take a look at what this looks like using long division. Okay, so first what we're going to do is we are going to divide. There we go. We are going to divide using long division as we would with whole numbers, all right? So a high school track is 9 7/600 meters wide. It is divided into 8 lanes of equal width for track and field events. We want to know how wide is each lane, right? And then it literally tells us that we are dividing, is divided, okay? And it says that it is 976 meters, and that's being divided into 8 lanes. Okay, and they're equal, so we know that we can divide the 2 numbers. So if I just look at my division problem, I know my division problem set up not as long division would be 9 7/76 divided by 8. Then I know my divisor always goes on the outside. And my dividend always goes on the inside. Right, my dividend in this case is 9 7/76. Line at the top. There we go. So let's see. Right now, since 8 is a whole number, we can go ahead and divide. When we're dividing with decimals, the divisor has to look like or become a whole number. So since it's already a whole number, we just go ahead and divide. So 8 goes into 9 one time. 8 times 1 is 8, so we subtract. So 1 times 8 is 8, subtract, bring down the 7. Remember before I told you we want to put a spot or a chair for each group? It's because when we divide with decimals, we bring our decimal straight up. So if we had accidentally put this 1 over here, our answer would be completely incorrect. So now I want to know how many times does 8 go into 17? It goes in twice. 8 times 2 is 16. Subtract, I get 1, bring down the 6. 8 goes into 16 twice. Minus 16 is 0, so I know my answer is done. So then I know that they can have 8 lanes, and each of the 8 lanes will be 1 22/100 meters wide. Okay. All right, so let's try this again. So I'm going to erase down here a little bit because I ran over my problem. So here I want to know what is the fee for one session. So what is the fee for one session? So aerobics classes cost $153 for 14 sessions. So if this is what it costs for all of these, I want to know what it costs for one session. So to figure that out, I'm going to use division. So if we're saying for one session, this is kind of like saying per session. And when we say per session, that tells us, in this case, that we have to divide. In this case, we're taking the money that we spend, the $153.86, and we're dividing it by the 14 classes that are being taken. Again, I set up my long division. I'm going to set it up over here so I have space. The divisor goes on the outside. The dividend goes on the inside. So $153.86. I'm going to put up a chair for each person in the party, except for the decimal for each number. Okay, can 14 go into 1? No. Can 14 go into 15? Yes, 1 time. Minus 14 is 1. Bring down the 3. Can 14 go into 13? No. So we actually do put a 0 here this time because we brought down the 3. Minus 0. We get 1, 3, and then we have to bring down the 8. Bring your decimal up right away. Usually this helps students with not forgetting to bring it down. So then can 14 go into 138? Yes, it can, and it goes in 9 times. 9 times 14 is 126. When I subtract, I get 12. Bring down the 6, which I know that can go 9 times, and I subtract 126, and I know I get 0. So then my answer in this case, because the decimal is between the 10 and the 99, each class costs $10.99. All right, so now I want you to take a minute, and I want you to come back, and I want you to see if you can get the correct answer. Remember, since we're dividing by a whole number, we don't have to move our decimals at all. We leave them where they are. All right, so bring that decimal straight up. Have my boxes. 5 can go into 9 once. Minus 5 is 4. Bring down the 7 is 47. 5 goes into 47 9 times. Minus 45 is 2. Bring down the 5 is 25. Goes in 5 times. So I know minus 25 is 0. So your answer should have been 1 95/100. Again, give everybody at the table a seat. Bring that decimal straight up. Can 7 go into 6? No. In this case, so you can put an X for now. Can it go into 64? Yes, it can, 9 times. Minus 63 is 1. Bring down the 4 is 14. 7 goes into 14 twice, which is 14, and I get 0. So I don't write my answer as X and 92/100. That X in this case does become a 0 because it is in front of the decimal. So I get 0 and 92/100. All right, so now we're going to take a look at the next example. For the next example, we have Ella, who uses 5/10 of a pound of raspberries in each raspberry cake that she makes. How many cakes can Ella make with 3 and 25/100 pounds of raspberries? So we want to know how many cakes. How many cakes can she make? She uses 5/10 pounds in each raspberry cake. She has 3 and 25/100 pounds. So what I'm going to do, okay, so for this problem, what I'm going to go ahead and do is I am going to set up my problem, as I usually do, as a division problem, because I know if she has 325/100 pounds, I'm going to put that into groups of 1/2 of a pound to figure out how many cakes she can make, because she needs 1/2 a pound for each. So then in this case, we're going to go ahead and set it up as long division. My divisor goes on the outside, my dividend goes on the inside. Now if you remember before, I said that on the outside, so this divisor, it has to be a whole number when we divide. So in order to make it a whole number, my decimal needs to be to the right of the last number in the decimal. So since I only have one number here, I have to move it to the right one time. But remember that golden rule. What I do to one, I have to do to the other. So then my new problem becomes 32 and 5/10 divided by 5. And then step 2 would be to actually do that division. So let's give everybody at the party a seat. Place the decimal right away. 5 cannot go into 3, but it can go into 30, and it goes in 6 times. 6 times 5 is 30. 32 minus 2, or minus 30 is 2. Bring down the 5. 5 goes into 25 5 times. So in this case, it says that our answer is 6.5. We have to think though, can she make 6.5 cakes? No, but she can make 6 cakes because she doesn't have enough to make a 7th, but she can make, so Ella can make 6 cakes. Even though her answer is 6.5, that means she can only make 6 full cakes. All right, B, Anthony spent $11.52 for some pens that were on sale for 72 cents each. How many pens did Anthony buy? So how many pens did he buy? Okay, so he spent $11.52 for pens that were on sale for 72 cents each. Each in this case tells us that we are going to divide. And we're going to take the amount that we spent and divide it by the amount per pen, and that should tell us how many pens we got, or Anthony got. So now I put the divisor on the outside, I put the dividend on the inside, but when I look at this, I notice this is a decimal. I need to turn it into a whole number. To turn it into a whole number, I have to move the decimal 2 places to the right. What I do to the one, I have to do to the other. So my new division problem becomes 1,152 divided by 72. And my decimal is down here. So again, we're going to put up seats for everybody at the party, just in case. Can it go into a 1? No. Can 72 go into 11? No. Can it go into 115? Yes, it can. It can go into 115 one time. Minus 72. 5 minus 2 is 3. 11 minus 7 is 4. Bring down the 2. Okay, how many times can 72 go into 432? I get 6. 6 times 2 is 12, carry the 1. 7 times 6 is 42, plus 1 is 43. I get 0. So that tells me that Anthony bought, my answer is 16. I didn't have to place the decimal because the decimal was back here. So Anthony bought 16 pens. All right, I'd like you to take a moment to pause and first change your numbers. Do your first step, come back to see if you changed it correctly. All right, so here you should have moved it one space to the right and one space to the right. So it should have become 42 and a half divided by 5. And now, since this ends in 5, you know that this will not have a remainder because anything divided by 5 ends in a 5. Here it was twice, so here it was twice. So here you should have 1,512 divided by 84 with that decimal being at the end. All right, now I want you to go ahead and divide, and when you come back, we'll check your answers. All right, so here we put up the seeds for our party. 5 can't go into 4, but it can go into 40 8 times. Minus 40 is 2. Bring down the 5, it goes in 5 times. Minus 25 is 0. There's no remainder. So I bring my decimal straight up, and I got 8 and a half. Here, put up all of my chairs. And it's really important here because this is where we usually make the biggest mistakes when we're dividing by a double-digit number. So here, 84 cannot go into 1. It cannot go into 5, but it can go into 151. And it can go in 1 time. And I get 84. 11 minus 4 is 7. This was 15. And this is 14. 14 minus 8 is 6. Bring down the 2. I know this can go in 8 times. 8 times 4 is 32. Carry the 3. 8 times 8 is 64. Plus 3 is 67. I get 0 left over. So my answer in this case was 18. All right, so you do have a lot of problems here with a lot of practice. What I would please like you to do all of the odd numbers. So for this one, sorry, I can't write over my shadow. You're going to do all the odds. Okay, so 1, 3, 5, 7, 9, 13, 15, 17, 19, and then you also need to do 21. Okay? If you don't get those correct, I would suggest that you try some of these even problems. As always, if you have any questions, please be sure to write them down or email me so we can go over them in class.